Hey you guys, it's Mary here. I'm the girl who loves maths. Welcome to today's lesson. In this video, I'm going to be teaching you all about factoring polynomials with 4 terms. The method we're going to use for this is called grouping. This is where we factor our polynomial by pairing up the terms based on common factors. Let's head on over to my iPad now where we can get started on today's lesson. Make sure you stick around right to the final example as this one's a little bit tricky. In this example, we are asked to factor this expression here. In our first step, we're just going to pair them up. I'm going to pair up the 6m cubed and the negative 9m squared, really because I can see here that they both have m's with a power greater than 1. And I can also see that 6 and 9 have a common factor, or 6 and negative 9 have a common factor of 3. That means that the positive 10m and the negative 15 are also going to be a pair. I'm just going to rewrite them using a set of parentheses so we can remember which we've paired up. You can see now that I've written them in their groups, and I've also separated them with an addition sign. That's how we begin our factoring by grouping. In our next step, we're going to focus on factoring each set of the parentheses. Let's start with 6m cubed minus 9m squared. I can already tell that the greatest common factor between 6 and 9 is 3, as 3 goes into 6 and into 9 perfectly. Then what I'm going to do is I'm going to focus on our exponents here. We've both got m in common. One is to the power of 3 and the other is to the power of 2. What I do is I just take the variable with the lowest power. So I'll take the 2 out. So we've got 3m squared. Now that I've taken out any common factors, I'm going to draw in a set of parentheses now. And then I ask myself, 3m squared times what would give me my first term, 6m cubed? Well, 3 times 2 will give me the 6, and m squared times m to the power of 1 will give me my m cubed. And just so you can recall, when we are multiplying here, we simply add our exponents. So we'll have m to the power of 2 plus 1, giving us the m cubed that we were hoping for from the 6m cubed. I don't need to write this power of 1, so I'm just going to get rid of it. Now I need to ask myself, 3m squared times what would give me negative 9m squared? Well, 3 times negative 3 would give me the negative 9. And I already have my m squared as it's hanging out the front here. So I don't need to put any other m's next to the 3 there. So what I'm going to do is shuffle my parentheses forward a little. On to factoring our next set of parentheses. The common factor of 10m and negative 15 is simply positive 5. So I'll pop that out the front of my parentheses. There are no common variables, so we'll just leave it at 5. I'll open up my parentheses. 5 times what will give me my first term of 10m? Well, 5 times 2 gives me the 10, and I'll just need to tack on an m to that to give us the full 10m. Finally, we need to ask ourselves, 5 times what will give me the negative 15? Well, positive 5 times negative 3 gives us the negative 15. We're not fully there yet. Check this out. They both have a common factor of 2m minus 3. So let's bring 2m minus 3 out as a common factor. 2m minus 3. I'm going to open up another set of parentheses, and then we ask ourselves, 2m minus 3 times what would give me this first term here? And the answer is I just have to multiply it by the 3m squared out the front, and that would give me my first term. Then we ask ourselves, 2m minus 3 times what would give us this second term? The answer is just that positive 5 out the front. And we're done. That's all we have to do to factor by grouping. I know it can seem a little bit strange at first, but basically all we did there was notice that 2m minus 3 was common. So we wrote that down as a common factor in one set of parentheses. And then in the second set of parentheses, all I did was pick up my terms that were out the front of each set of parentheses and pop them in a set of parentheses of their own. So we'll jump into example number 2 so we can go through those steps again. In this example, we are asked to factor this expression. I'm going to start again by just grouping them. I'm going to group these two together and these two. I've got my 3d cubed minus 3d squared. And then we separate each set of parentheses by an addition when we're pairing. And then I'm left with 5d minus the 5. What we need to do is factor each set of parentheses now. Let's start with the first one. The common factors here are 3 and d squared, because 3 is the greatest common factor of 3 and negative 3. And then I've chosen d squared because we have d to the power of something after each of the 3's. And we always take the one with the lowest power, so d squared in this case. I'm going to open up a set of parentheses now. 3d squared times d will give me the 3d cubed, which is my first term. And then I'm just going to subtract 1, as 3d squared times negative 1 would give me the negative 3d squared, which is my second term in that set of parentheses. We've finished factoring that one now, so moving on to the second set of parentheses. The common factor of 5d and negative 5 is just 5, so I'm just going to write plus 5. 5 times d will give me the negative 5d. And then I'm also going to write negative 1 because 5 or positive 5 times negative 1 gives me the negative 5, which is the second term in that set of parentheses. What you might have noticed again is that we've got a common factor here. So let's bring that out the front and write it down. So d minus 1 is our common factor. And then all we really need to do is just pick up our leftovers and pop them in a set of parentheses on their own. And there you have it. Example 2 complete. Let's go for one more, as the third example is a little trickier. In this example here, we're being asked to factor this polynomial. I'm going to pair them up like this and rewrite them. Okay, now let's factor each set of the parentheses. I'll begin with the first one. The greatest common factor of 9c cubed and negative 9c squared is 9c squared. Open up a set of parentheses. 9c squared times c, or c to the power of 1, will give me 9c cubed. And then if I just subtract 1, 9c squared multiplied by negative 1 would give me the second term, which is negative 9c squared. On to our second set of parentheses. The common factor of negative 25c and positive 25. I'm going to say that negative 25 is the common factor there, and I'll show you in a moment why. Let's just finish factoring it in this way first. I know generally you'd want to take out positive 25 as the common factor, but I'll show you why it doesn't work in this case as nicely. So we'd have negative 25 times c would give us the negative 25c, which is the first term. And negative 25 times negative 1 would give us the positive 25, which is the second term. And you'll see here that we've got our c minus 1 as our common factor. Let me just quickly show you what would have happened if you took out positive 25 as the common factor instead. If we took out positive 25 as the common factor, well, 25 times negative c would give us negative 25c, and positive 25 times positive 1 would give us the positive 25, which was the second term in the second set of parentheses. You'll see then that negative c plus 1 doesn't match c minus 1. So that means factoring by grouping wouldn't actually work properly. That's why it's really important, if this happens to you, to think, okay, maybe I'll take out a negative common factor instead. That can often help the situation. So now that we have that, we know that c minus 1 is our common factor, so we'll write that down. Then we've got our 9c squared and negative 25, so we'll put that into its own set of parentheses. You might be tempted to leave it here, however, we can keep going. That's because we can use our perfect square rule for this set of parentheses. You might recall the perfect square rule. It states that if we've got the subtraction of two squares, we can actually write it like this. So let's try and use that rule. We know that we've got our c minus 1. Now the 9c squared minus 25 can be written like this. We can write it as 3c all squared. That means that our 3 is getting squared too. So 3 squared gives us that 9, and c squared gives us the c squared attached to that 9. Then we can subtract 5 squared, as 5 squared gives us the 25 there. Now that we have them written in the same form here, we can go and substitute them into this. So again, we have our c minus 1 and 3c squared minus 5 squared. That 3c works as our x, and the 5 works as our y in the formula. So we've got 3c plus 5, and then we've got 3c minus 5. And there we go, we've finally finished. Hooray! Thank you so much for watching, and as always, if pre-calculus is what you're studying, you can find a link in the description section below that will take you to my course that you can try out for just $1. I'll catch you in my next video. Bye!